Hey, do you know what they feed a baby parabola? Oh, quadratic formula. Oh, okay. All right, we're studying parabolas here. It's all about the first type of conic section that you learned about in the lab. And in this case, our conic section is a familiar one. We've seen our quadratic functions before. All right, we know them as parabolas, and now we're going to investigate them from a different perspective, a different definition. And that's the definition of a parabola based on what we call a focus and a directrix, a line and a point. So let's take a look at what we're going to explore today. We got some introduction, give you the formulas and ideas of what we're going to do, and then do some examples, both creating our equations and graphing from equations. So let's get going here. A conic section, if you'll remember, is the figure that's formed when a plane intersects a double right cone. All right, so we got parabolas and circles and ellipses and hyperbolas. And this plane right here in the orange is what we're looking at. So if we were to orient that plane just in the right way, right, we would orient it in a way where it only intersects like the top half of the cone or the bottom half of the cone, right? You see how it's tilted, not quite enough that you get a hyperbola where you see two branches, as we'll call them, but here we just see one branch right here because it's parallel in just the right way to the slope of the cone. So our parabola is going to be one of the shapes that we call a conic section because it's a section of a cone. So it is. All right. And a parabola is defined as the set of points that are equidistant from a fixed point, which we call focus, and a specific line, which we call the directrix. So in this case, the distance between the focus and the vertex is 2. Distance between the vertex and directrix is also 2. And any point that we take that's on the green parabola here, if we were to draw a line going to the focus and a line drawn to the directrix, we would see that they're the exact same distance. And in this Desmos activity, we can see that we've got a focus right here and a directrix. And the equation that we'll form in just a second has to do with three actual constants, h, k, and p. In this case, x minus h forms whatever is going on with a horizontal shift to the parabola. Y minus k forms a vertical shift. And then the p is going to tell us how far our focus is from our vertex and how far our directrix is from our vertex. So as you can see, when I change h, right, you see in the equation right here, it changes what's happening with our shift with the x. Right, you can see I shift my vertex either to the left or to the right. With k, that's going to shift our parabola up or down, and it moves everything with it. And then p is going to be our change to our distance between our focus and directrix. So when I increase p, you'll notice that the parabolas of focus and directrix move farther and farther apart and farther from our vertex. And in fact, when I make p equal to a negative number, our focus falls below the vertex. Okay, and our directrix then becomes above our vertex. And the other thing that's noticed is that when I increase the distance from our focus to the directrix, it also flattens out our parabola. It's going to be a skinnier parabola when my p-value is smaller and smaller. That is when our focus and directrix are so close to each other. The vertex, or excuse me, the parabola bends in towards its focus, and it's almost like it's repelled by the directrix. It moves away from it, so that we're moving in towards that focus and away from our directrix. Okay, so what is this equation right here? Well, we've got h, p, and k, and our first equation we'll see is a parabola that either opens up or down, and this is x minus h squared is equal to 4p times y minus k. So in this case, p represents the distance between our focus and our directrix, or our vertex and directrix as well, going in the other direction. It's easy, I think, to remember this because this is our normal parabola right here, like y equals x squared. We know as a parabola that opens up. Y equals negative x squared would be a parabola that opens down. So when the x component is what's squared, all right, we have our general form of a parabola that opens up or down. Other key features, this one opens vertically, as I said, opens up or down. Vertex is at h comma k. Focus is at h comma k plus p. So if we add the value of p to this, all right, we get where our focus location is. And then our axis of symmetry goes right down the middle, right at where our x coordinate is for our vertex, right? Because this is opening up, it's symmetrical in a horizontal direction the other way. And then finally, our directrix is going to be k minus p, right? So wherever our y coordinate is, we're going to subtract p and go down to where our directrix is. And yes, it is an equation of a line, So a focus is a point, directrix is a line. We can also see where we've got a picture that opens the other way. In this case, we have y minus k squared is equal to 4p times x minus h. And in this case, the y is squared, and then when the y is squared, we're going to either open left or right. So it opens horizontally. Vertex is still at h comma k. The focus is at h plus p comma k. All right, so we're going to add the p-value to our x-coordinate because we're going to open either left or right, so it changes horizontally. And then our axis of symmetry runs right through the middle of the parabola. All right, you see that it's symmetrical both above and below the vertex. So our symmetry line is a y equals k, so it's a horizontal line there. And then the directrix is a vertical line. You can see again that this parabola is repelled by the directrix and moves in towards its focus. And the equation would be x is equal to h minus p. I would not necessarily memorize all this. Right? You know where the vertex is, that's important for sure. But the value of p is either added in whatever direction we're going to find the focus, and then subtracted in whatever direction we're going to find the directrix. It's the opposite way for directrix. So here's an example. Suppose y minus 2 squared is equal to negative 12 times x plus 1. Identify the vertex, focus, axis of symmetry, and directrix, and then graph the parabola. So in this case, all right, what we need to notice is what's squared. That's a key part to this. And then whether our coefficient out front of the linear term, the x plus 1 in this case, is a negative or a positive. So you'll notice that this matches the y minus k squared formula is equal to 4p times x minus h. So it's just a game of matching in this case. So what's with the x? Well, it's x minus a negative 1 gives us an x plus 1, so h is negative 1. K is 2. We've shifted up 2 units. That's the y minus 2 part. And then we just set 4p equal to whatever constant is in front of our linear term. It has to be in this form. We'll see one that's a little bit different in just a second. So 4p has to be equal to the negative 12, so p is negative 3. That tells us a couple things. The vertex has to be at negative 1 comma 2, that's h comma k. And then since y is squared, the parabola either opens left or right. Well, which one is it? P is less than 0, so we have to go to the left to find our focus, which means we're going to open in towards the focus, going towards the left. So therefore, our focus is going to be negative 1 minus 3 comma 2. So we have to subtract the x-coordinate because we're going in the horizontal direction to find our focus, and we get the point negative 4 comma 2. The axis of symmetry will be the y horizontal line that runs right through our vertex, so it has to be y equals 2. That's the y-coordinate of our vertex. And then the directrix is to the right of the focus, so in this case, we're going to add 3 going in the other direction to get the line x is equal to 2. So it's 3 units to the right in this case. And then here's your graph. We go in towards our focus, away from our directrix, and the vertex is right in between. Suppose 1/16 times x plus 4 squared equals y minus 1. Identify the vertex, focus, axis of symmetry, and directrix, then graph. You'll notice this is not quite in standard form. Right, so what we need to do is multiply both sides by 16 to make it match the x minus h squared. Set that equal to 4p times y minus k. When you do it like this, it's easy to see, hopefully, that h is negative 4. Negative of a negative 4 makes it plus 4. K is equal to 1, and 4p is equal to 16. So we multiply both sides by 16 to make that coefficient be in front of the linear term. When you find out, divide that out, you get p is equal to 4. So that means, right, a parabola is going to open up because it's an x squared, and p is a positive number. So our vertex is at negative 4 comma 1 because that's h and k, and our p is positive, so we're going to add 4 to our y-coordinate to make this go up towards its focus. All right, so our focus is at negative 4 comma 5, and you guessed it, the directrix is going to be 4 units below the focus, so that's y equals negative 3. So here's the graph, and then the axis of symmetry runs right through the graph right here. In this case, it's x equals negative 4 because that's the x-coordinate of our vertex. All right, so sometimes you don't see parabolas written in standard form, and we're going to have to figure out what that means. So let's say we have 3y squared plus 6y plus 27 is equal to 24x, and we want to do all the same sort of things with this that we did before. So notice that we don't have it in standard form, so what we're going to have to do is what's called completing the square. All right, and we're going to complete the square in the squared term. In this case, it's the y squared. So first step, you want to move all your constants to the linear side. And then what I'm going to do is I've got a 3y squared plus 6y. All my y terms are on the left here. If I were to factor out a 3, all right, I get a y squared plus 2y plus a number that I'm going to fill in both on the left and right to balance my equation. In this case, when you complete the square, divide your middle term by 2 and then square it. So 2 divided by 2 is 1. 1 squared is 1. So I'm going to add 1 to the parentheses. And then that means that I added a 3 times 1 to the right side to balance it out. So this becomes 3 times y plus 1 squared is equal to 24 times x minus 1, because this all reduces to a negative 24. We'll get some more practice with this in class, but basically now we've got it in standard form. And if I divide by 3 each time, or each side, then we get a y plus 1 squared is equal to 8 times x minus 1. Just like before, now we can find out that h is 1, that's with the x, k is negative 1, and then 4p has to be equal to 8, that's the coefficient on our linear term, so p is 2. The vertex is at 1 comma negative 1, that's h and k, and we know the parabola opens right since y was the squared term and p is positive, so we have to go forward to get our focus in the rightward direction. When I add 2, that's my p-value, to my x-coordinate, I get a focus of 3 comma negative 1. And then the axis of symmetry runs right through the middle of that parabola. That's y equals negative 1. And the directrix is to the left, 2 units, so we get x equals negative 1. And here's the graph. We open in towards our focus, away from our directrix. Now, what do you do if you have characteristics and you want to find an equation for it? Well, generally, this is actually a little bit easier, right? Because all you got to do is find the p-value and then figure out what's going on with the vertex. So if we knew that the focus was at negative 6 comma 1 and the vertex was negative 6 comma 4, the focus is below the vertex right here. So this is a parabola that opens down, which will tell us that we want to use the x squared one. Up and down means x squared. All right, and then we'll have to figure out what p, h, and k are. Well, the value of p has to be negative 3 since we went down 3 units, all right, to find where the focus was. That'll also make the directrix y is equal to 7 because we go up 3 units for the directrix. And so, since we know that the vertex was at negative 6 comma 4, we get x plus 6 squared equals negative 12 times y minus 4. All right, that's our h and k values that were already given here. So in summary, a parabola is a particular type of conic section defined by a distance to a point, focus, and a line directrix. And different equations can be used to describe parabolas based on whether the parabola opens up, down, left, or right. Thanks for listening. We'll see you in class.